Okay, let's look at a couple of more integrals using fundamental theorem of calculus part 1. Part 2 we're going to use a lot and we're going to love it. But part 1, here we go. It's a little bit more tricky. Remember that if I just work out a real quick one here, I'll just set it up and work it out really fast. If I go from 0 to x of t squared dt, and I take the derivative of that, then what I end up with is x squared. Okay, that's what I end up with. Well, if you'll notice right off the bat with this first guy right here, the x is on the bottom and the 5 is on the top. Well, not a big deal. Remember that one of the things that we learned from our properties of integrals is that we can trade around these upper and lower limits of integration. And if we trade places, we just put a minus sign in front. So what if we looked at this? Y equals negative, and then the integral from 5 to x of 3t sine t dt. Now we can just use the fundamental theorem just like we've seen in the past couple of slides. We're just going to apply the whole derivative rule. So if I dy this guy, if I dy that whole guy, take the derivative of the whole guy, what's going to end up with is negative 3x sine x. And that's all there is to it. It's pretty user friendly. Now look over here on this guy. We go from 2x to x squared. But how is that going to work? Now we've got variables on both sides. Well, one thing that we can do is we can split this up, and we can write it as two separate integrals. And again, it'll be using some of those rules. So we don't know where x goes or starts or stops or anything like that. We just know that it's always changing. And so what if I split this integral up into two integrals, something like this, from 2x to 0 of 1 over 2, whoa, that's a bad looking 2 plus e to the t dt, plus the integral from 0 to x squared of 1 over 2 plus e to the dt. Now, if you'll look at these two guys, what we have is a situation where we're taking one integral, adding it to another integral, but we're getting the entire integral that we originally starting with, because we go lower limit of 2x to 0 and then picking up right where we left off at 0 and going to x squared. So we get all of those values of x in between that we have to have. The problem is now I've got this 2x on the bottom. Well, the first example that we did today fits this situation perfectly, where I can actually work with the negative integral from 0 to 2x of 1 over 2 plus e to the t dt, plus the integral of 0 to x squared of 1 over 2 plus e to the dt. Now, the only other thing that we've got to do here is use our chain rule, because we don't have just plain old x up there in our upper limits. So if I let u equal to x, if you rewind back to the previous slide, we talked about chain rule. So basically what I'm going to do is multiply my integral by the derivative of 2x, which would be not du, it would be du dx, which is equal to 2. And on this other side over here, we would let u equal x squared. And so we would multiply by the derivative of that. So du dx is equal to 2x. And really, that's all we're going to do. And the t becomes the 2x, and we multiply the whole thing by 2. And the t becomes x squared, and we multiply the whole thing by 2x. So what does this last guy look like then? Well, I'm going to have, when I take the derivative of this whole thing, d dy, of this whole thing right here, what I'm going to get is negative 1 over 2 plus e, and then instead of a t, I've got to put my upper limit of integration. Remember, that's what the u is, times 2 plus 1 over 2 plus e. And then again, my upper limit of integration right here, where the t is going to be this x squared times 2x. Let me move that over a little bit. Because that's the derivative part. And so you're going to get a really wacky answer here, and that's okay. Here's your answer. -2, and these could be in either order as long as the signs are the same. 2 plus e to the 2x plus 2x over 2 plus e to the x squared. And that's it. Now this looks really wacky, but it's not a big deal. Just be patient, watch this video, watch the one right in front, and you'll see that there's just some really simple steps that we do to work through this complicated problem.